Alright, so today we're starting 7.2. We're looking at the first set of problems, and it says to graph these and compare them with 1 over x. So on my calculator, I'm going to put in y1 what I'm supposed to be comparing them to, which is 1 over x. And then I'm going to plug them individually into y2. But first, let's hit graph, so I know what that looks like. And see if I can make sure my graph is window set up correctly. Mine is not, so I need to hit zoom 6, change my window, and there we go. Okay, so I have this right here. Now, my window is still zoomed out a little bit too much. So let's change that to -5, +5, -5, +5. Hit the graph, and let's see what that is. There we go. That gives me a little better window for this. All right, so there is y1. That's what we're comparing to. Well, let's graph number 1, which is 2 over x. So alpha y equals enter 2 over x. Graph. All right. So it looks very similar. It's just out a little bit further. So for number 2, what we see is a vertical stretch, stretching it by 2. Okay. If I come down here and I change that 2 to a 9, well, it's going to be a vertical stretch by 9. So I should see it stretched out even further. See, it's way out here now. So for number 2, I have a vertical stretch by 9. Well, for number 3, I should have a vertical stretch by 4, but there's a negative right there. What difference is that going to make? Well, a negative means a reflection. So let's look at this. If I come up here and I put a -4 in his graph, well, I'm reflecting it about the x-axis or the y-axis, actually, because it's rational. It doesn't really matter. I'm going to do the same thing. So a reflection and a vertical stretch by 4. Okay. So that's the first 3. Let's look at our next set. It says, graph the function, state the domain, and range. Okay. So I'm going to put these on our paper. So let me first write down. We're not going to do all these. We're just going to do one of each type. 3 over x plus 2. So we'll do number 4. We'll do number 7. We'll do number 10 and number 13. So let's see that first column. So I'm writing them down on my paper. Switch to Canva so you can see the problems as I'm working. So, see problems right there. So let's look at number 4. Number 4 is in a different form than the other 2. We actually like this form better. It makes it a lot easier. Right? This is called transformational form because it shows me my transformations. This number on top is my vertical stretch or compress. Okay, in this case, I'm stretching by 3. So this is a vertical stretch, a vertical stretch by 3. That plus 2 on the outside means up 2. And then there's nothing here with the x. So this has not been shifted left or right at all. Okay. So if I try to graph it, well, my normal one looks like this. We just saw the graph of the normal one. So I'm stretching it and I'm shifting it up 2 units. So 1, 2. So now it's going to look something like that. Okay. Now, if you want to graph this one on your calculator, that's fine, but please write down the transformations. But most importantly, it said domain and range. Well, my domain is going to be whatever I move, however direction I move, left or right. Well, I didn't move left or right at all, so my domain is x not equal to 0. Okay, vertical asymptote, x not equal to 0. If it had moved left 2, then my domain would be x not equal to -2. If it moved right 2, x not equal to +2. If it didn't shift left or right at all, then my domain was x not equal to 0. Notice I can't put 0 in for x, so I get divided by 0. Basically, my domain is whatever I cannot put in for x, into x without getting divided by 0. My range is going to be y not equal to, well, notice I have a horizontal asymptote here at +2. So my range is going to be y is not equal to that number right there, in this case, 2. Okay, so this is the part it's really asking. If I look at number 7 is actually in the same form as number 4. There's no number added to the end, which means it's not shifted up or down at all. There's just a 1 on top, which means there's no vertical stretch or compress. Okay, the only thing is a +4 there. +4 there means left 4. Well, if I graph it left 4, 1, 2, 3, 4. That. But again, what I care about is domain and range. Domain. Well, left 4, the value I cannot plug in here is -4. -4 plus 4 gives me 0. My domain is x cannot equal -4. My range, well, it's not shifted up or down at all. So my range is y cannot be 0. So just like over here, domain by default was 0. Range, if it's not shifted up or down at all, by default is 0. Well, let's move on to numbers 10 and 13. These are a little different. Here I have x on both top and bottom, not in transformational form. Now in the next section, the next set of problems, we're going to learn how to go from this to this, but for right now, I don't need to. All I really need to know is where is my vertical asymptote? Well, my vertical asymptote is wherever this equals 0. Well, what minus 2 equals 0? I can write it out. This right here, x minus 2 equals 0. So let's add 2 to both sides, and I get x equal +2. That's where my vertical asymptote is. Okay, so that tells me my domain is x cannot be 2, because that's the number that if I plug into the denominator, it gives me 0. Okay. Well, what about my range? Well, my range is going to be the number in front of that x, which is just a 1, the number in front of this x, which is just a 1, divided by each other. So my range is y cannot equal, well, in this case, 1 divided by 1, which is just y cannot be 1. Okay. If I graph this, that's my horizontal asymptote. So 1 is right there. Put a little dotted line on my vertical, dotted line on my horizontal asymptote, and draw my graph. Come over here to this one. Well, what gives me 0 in the denominator? So 3x minus 9 equals 0. Add 9 to both sides. 3x equals 9 divided by 3. and I get x equals 3. So my domain, x cannot be 3. That's when I have a vertical asymptote. Well, what about my range? Well, again, I look at the number in front divided by the number in front. So my range is y cannot be 5 over 3. That's the number on top divided by the number on top, the coefficients. If I graph it, well, my vertical asymptote is at 3. 1, 2, 3. Put a dotted line there. My horizontal asymptote is at 5/3. Well, that's almost 2, but not quite. That. Okay. That's number 13. Let's see here. If I look at the next section, they say, well, how can I go from the problems like 10 and 13, the ones you just did, and change them into transformation form? Okay? Change it into transformation form. That way I can actually identify what those transformations are. So we're going to do 2 problems. We're going to do numbers, let's find 2 that are different. 16 and we'll do 20. 16 and 16 is 4x plus 5. 20 is x plus 15. X minus 5. To do this, we're going to use long division, which we have learned before. We're just putting it along. So long division is I take the top part, put it inside the long division circle, 4x plus 5, put the denominator outside. This is going to be a super basic long division problem. We're going to have the first term divided by the first term. 4x divided by x. Well, 4x divided by x, the x cancel out. Now left with 4. Well, after I do that, distribute the 4 to both of those. 4x, 4 times positive 1 is positive 4. Distribute, I'm going to subtract. My first term should always cancel out. 5 minus 4 is 1. That's my remainder. Okay. Well, what does that mean? This means that I can write this in the form of, well, this is my remainder. So we're going to say the remainder, which is 1 over what I was dividing by, plus, because that number on top is positive, 4. Okay. So the number on top goes here. If it was a negative 4, I put a minus there. The remainder goes on top of whatever I was dividing. That's how I change it to this form. So what does that allow me to do? Well, that 1 on top tells me I do not have any kind of stretch or compress, no vertical stretch or compress. This right here, that plus 1 tells me that I went left 1, and that plus 4 tells me up 4. Okay. circle that too, because part of minus as well. Let's look at number 20. So dividing x minus 5 into x plus 15. X goes into x one time. I distribute that. X minus 5. I need to subtract. My first term should cancel out. And be very careful here. This is 15 minus negative 5. Well, 15 minus negative, minus a negative makes positive. So 15 plus 5 is 20. Now I can rewrite it. So this is, again, the top, sorry, my remainder goes on the top, what I'm dividing by. And then what goes on top here is right there. Okay? So that 20 says vertical stretch. Pick it up so you can see. Vertical stretch by 20. That minus 5 right there. So right 5. And that plus 1 up 1. Okay. Finish. Let's look at number 23. So this requires taking a trip. The trip has an initial cost of $500 plus $150 for each student. And it says how much money how many students must go on the trip for the average cost per student to fall to $170. Back on. Small first. Let's start off. Well, my trip costs how much? Well, it costs $500 plus. Well, for every student, it costs an additional $150. So technically, if no students went, the trip would still cost $500. If one student went, it would cost $500 plus $150. If two students went, it would cost $500 plus $300, becomes $150, and so on and so forth. So my formula is going to be 150 times how many students. So we'll say 150 times x. Which then says, well, average cost. Well, average would be, well, I take this and divide it by how many students are going. Well, how many students are going is x. So I get that. And I want that to equal 175. Well, let's see what that gives me. So I'm going to stop here for just a second so you can see that a little bigger. There's the equation I have. I can plug this in my calculator just the way it is, but just to show how this is similar to what we've been doing, I'm going to simplify this a little bit. I'm going to say this is 500 over x plus 150 x over x equals 175. And then I can say this is 500 over x plus, those x's cancel out, and I'm left with just 150. So now it's in transformation form. You didn't have to do that, but I wanted to show that this is the same thing as what we're doing. Okay? So there's that. I want to make this equal 175. How do I do that? Well, I can just use algebra. Subtract 150 from both sides. 500 divided by x equals 25. Multiply by the denominators, and we'll multiply both sides by x. 500 equals 25x divided by 25. And let's see here. 25 goes into 100 4 times, so it has to go into 500. 5 times 4, which is 20. So x equals 20. I would need 20 students. Okay. Now, to answer part B, and then maybe to show you another way to answer part A, I could have used my calculator. So let's share screen. Okay. To do that, we'll go to the y equals. And to make my calculator solve the equation, I could just plug the left half of my equation into y1, the right half into y2. So I'd say 500 plus 150x over x. And then for y2, I wanted that to equal 175. I'll hit a graph and see just a little glimpse of something, and that's okay. Knowing that my answer is going to be greater than 5, I'm going to need to zoom out. So I'm going to change my window. I don't care about negative values because I know I'm not going to have negative students. So let's see here. So 0 is really the smallest number I can possibly get. Biggest number, I'll say, well, maybe 100. Y value is the cost. Well, 0 is the lowest it could be. The largest, I'm going to say again, is, well, if it's 150 per student, only one student went, it would be 650. So let's go with that, 650. Okay. So see, there's the equation of my code. Oh, and there it crosses. So you see, 175 crossed the equation of my how much it cost. So let's see how do I do this? Well, I'll say second count, go down to intersect, which is number 5, and just hit enter twice, or sorry, 3 times. It thinks about it for a second, and then it comes up with x equals 20, which is how much money it would, or how many students it would take for the average cost to be 175. Well, that's great. It tells me I did the answer in part A right, but what about part B? It says, what happens to the average cost as more students go on the trip? Let's pick off that 175 now and look at the graph. Well, what's happening to my curve? My curve is getting lower and lower. Okay, so that means as more students go on the trip, the cost decreases. So the answer to part B is, as more students go on the trip, the cost is going to decrease. And then for 23, 24, and 25, we're going to go back to calculator, zoom 6, and we're going to put it in our calculator. Okay. It says, figure out if it's even, odd, or neither. And so we will first graph the first thing, and then I'll explain what that means. 5 over x squared minus 5. So if it is even, that means it is symmetrical about the y-axis. If it is odd, then it's symmetrical about the origin. And if it's neither, well, then it's neither of those. So let's look at ours. Well, I see that on the right half of the y-axis, it's just mirrored about the left half of the y-axis. So this one is symmetrical about the y-axis. So this one is even. Let's try the next one. 3x squared over x squared plus 4 graph. Okay, again, whatever it does on the right half of the y-axis, I can see it's doing the same thing on the left half. So again, this one is also even because it's symmetrical about the y-axis. Now equals the 3 of the exponent, 2 for the 2 is a coefficient there, and right here we want x to the this one's really just hugging the x-axis, so I need to change my window. So I'm going to change my leaving x values the same. I'm going to make my y value to -1 and +1, just so I can really zoom in or stretch my graph vertically to see what's going on. Right? So notice that if I start at the origin and I go this direction, it does exactly the opposite going the other way. This is symmetrical about the origin. If it's symmetrical about the origin, that's what makes it odd. Okay? And that's how you do 7